All right, YouTube, we are back at it again. Oop. So, I have a project that I've wanted to do for YouTube for quite a while now, and I'm finally getting around to it. This video is going to be a little different than my previous ones where I'm reviewing items or trying to give you my thoughts on stuff I've been EDCing for years now. And what I want to do today is I want to design and 3D print one of these. So this is what's called a spinner handle. It's basically just a screwdriver handle molded onto a long 1/4-inch drive. When I found out these existed, I was very excited to get one. I love this handle. I use a style of this handle all the time at work, and I use them at home too. They're really nice for, you can break torque on something and then rotate it off that way, or if it's light enough anyway, you just throw your socket on there and then you got a nut driver, I want to say they call those. And I really like this handle. You can get this one pretty cheap. This is only like 10 or 12 bucks on Amazon. But the point of the video today isn't necessarily this one. I want to 3D print one and make a larger one, because you can easily find 1/4-inch drives of these, but you can't easily find 3/8 or 1/2-inch drive of these. And I think those would be very nice to have. So much so that I've actually already done a version of this in the past. These two, 3/8 drive extension and a 1/4-inch extension, are both 3D printed. And they have held up surprisingly well. This one I actually modeled very similar to this one. So dimensionally, very close to the same thing. I use these at work all the time. By these, I mean these two. I usually keep this one at home. But I want to print a new one today, and I want to take you guys along for the ride, because I'm going to be designing it from scratch in Fusion 360 and 3D printing it. And I thought it would maybe make for a interesting video for you guys to watch. Now, I'm going to do it a little differently. I want to make the handles shaped like this. This is a Vessel branded, I don't know if you're going to be able to see the name, a Vessel branded hex driver. I very much like this tool as well. It handles a different function, whereas if I put a driving extension in it and then I say get a Phillips, now I have a screwdriver. So what I want to do is I want to 3D print a handle shaped like this. I really like the ball grip. It obviously won't be rubberized like this because it'll be 3D printed plastic, but that's okay. And I'm going to use these Pittsburgh wobble socket extensions as the platform for it. That is actually what this one is made out of. I believe it is that one right there. So I'll probably be talking a little bit more about 3D printing and the intricacies of that as I'm designing. I'll probably be talking about my design a little bit. I'm going to try not to make the video too long. If you guys are interested in a more exactly how to from scratch design tutorial or 3D printing guide, let me know in the comments. That is definitely a video I've wanted to work on, and with some feedback, It'll give me a little bit more direction with it. So anyway, let's get to it. Next video next part of this video should be me in Fusion 360 modeling some stuff up.
All right. I don't really have a plan of attack for this, so we're just going to kind of go for it. I will be using Fusion 360 software. This is Autodesk program. This is what I do almost all of my design work in. If I just go to like previous projects, these are all things that I've worked on in the past, or things that I've modeled for my Etsy shop, things that I've modeled for work, all sorts of things, and this is just one of my categories. But we're gonna get right into trying to design this spinner handle. I don't know if I'm going to talk through the whole thing, because I imagine this would be too long of a video. I might time-lapse some of this. We'll end up doing this as a revolve function. So we'll design basically design on the center line, and we'll design half of it, and then we'll revolve around, and that'll give us our 3D model of it. And I'll show you that once we get there. Okay, so now what I want to do is I want to make a center line for all of that. And did I dimension that? Yes, I did. There we go, 40. So now if we finish that sketch, we use our revolve tool there, grab the features we want to revolve around our axes. Boom. There is the rough shape of the handle. Not too shabby, eh? First things first, now that I'm thinking about it, we know we're going to have to make the bottom of this handle flat, because I need to be able to print it. And I'm going to print it on this face down here. So I think what I want to do is I want to add a preemptive flat there. We'll give that a dimension. 15 millimeters sounds great, but if I want to change it, I can always change it. But for now, 15 looks good. So when we revolve, we'll just not revolve this piece, and then it'll stay flat. Get out of our analysis. We can turn off that sketch so it's gone. We know we have the hole now. So now it comes down to, do we want to do any prettying up of it? And I think we do. So if we take fillet tool, grab maybe this edge, that's not bad. Okay, I like that. This is the surface I'm going to be 3D printing on, so I usually add a slight chamfer just to try to reduce what's called elephant's foot. So when you do your first layer of 3D printing, it squishes the plastic down on the plate a little more than the layers above it. So if you have a straight edge, it will, or a flat plate with straight edges on the plate, you'll get what's called elephant foot, where it squishes out just a little bit, and then you have a sharp kind of edge all the way around the base of your print. This gives your G-code a kind of like a scooch in on that initial layer and then build up normal after that. And when you scooch in, it reduces that elephant foot. It makes the squish come out basically even with the rest of your print, and it should come out fairly flush. That's always going to be different on printer. I've been using 0.25. It works pretty good for me. You might find that you need a little bit more for your printer. Also, wear on nozzle matters. Leveling of the bed matters. There's a lot of variables to that, but at least for me and my printer, that works pretty well most of the time. Okay. Now we're gonna 3D print that. Select that. Okay. So this is my CrealityPrint slicer software for my 3D printer. I use a K1Max. I'll end up doing a little video of that so you guys can see it in action and see the setup. This maybe isn't the best slicer software out there, but this is the one that they optimized for this printer, and it's worked really good for me, so I just continue to use it. They update it. They've added good things to it. I don't hate it, so I've been using it. So back to Fusion 360. We'll go back to our spinner handle, quarter drive, open, bingo, bango. Let's look at some of our settings. 0.2 layer height, that'll be fine. Wall loops, let's do 3. And now this is the infill question. I'll show you the difference between them, but I think I want to do 100%. We'll slice the plate. This gives me a line for line what this is going to do. You know what? I don't think I want to print it solid first. I think I want to trial print it so I'm not wasting the plastic, because I need to know that it's going to fit, and I need to know that it looks good and makes sense. So let's go back to 15%, and we'll call that grid. So now you'll see there's voids, there's empty spaces there. Which realistically, function-wise, this will still function totally fine with the infill like this. But like I said, it'll give you kind of like an empty feeling plastic item. It won't feel very robust. I find that these solid prints feel more robust. This will take about an hour to print. And okay, so we're in the print stage. Printer just got started. This is my K1Max from Creality. Really awesome printer if you're ever in the market. A little pricey, but it's so fast and it's so good. It's easy for me to recommend. if you want to get into the 3D printing hobby. Now, I didn't want people to say like, oh sure, that's nice, you can make a $15 spinner handle with you know, almost $1,000 printer, but I don't have one of those. Well, that's why I'm also printing with this guy. And he looks like he's doing just fine. He's going to be a bit slower, probably a third of the speed that my K1Max is going to go. But you can get an Ender 3 printer for $100 on sale sometimes, $150, and then you could be doing projects like this. But I sure do love the speed of this one. Well, once this is all sorted out and I have some handles, I will bring you guys in closer and see what the results look like. All right, here we are. We've gone through the whole process. We started with our idea, we modeled it up, we sliced it in our slicer software, we printed it, 2 different printers. You'll see I ended up making a quick iteration on the shape, and I'll show you why. And then we ended up I ended up having to change the size a little bit. I'm not quite done there yet, but it'll get there. It's a work in progress. But this was what came off first. Turned out pretty good. And then this is proof of concept that you don't need an expensive printer to do what I just did. The software I'm using is free. And that printer you could probably buy for $100, $150. And I mean, line for line, they both look good. So there's that. But one thing you'll notice is I oopsed a little bit in the modeling. I didn't put a length parameter on that. Taper's a little different. I'm not too worried about that. Same with there, the taper's a little different. Not too worried about that. It's minor stuff, just visuals. But it was kind of killing me not having the band. So last but not least, basically the final product. There we go. Model the band in. Fix that. Comparison to original, pretty darn close, all things considered. They have a couple of slight differences, but nothing that's going to bother me. There we go. Now, I'll end up putting these files on my Thingiverse. And so that's actually, if you have your own 3D printer, you'll be able to pull these files, buy a set of Harbor Freight extensions, and you'll be able to make these yourself. I'm gonna tweak the files a little bit before that because I really want it to be an easy assembly, and I really want it to probably be held with glue instead of press fit like I have. This did not go on super easy. It's there. But yeah, I'm super happy with the shape. I already modeled up the 3/8 version, so that's basically just a bigger hole in it. For me to do a 1/2 inch, I'll probably have to expand out some of this geometry a little bit to account for it. It'll be an overall bigger handle, but same shape. All the handle types will end up on the Thingiverse. If they're not there,
right when you watch this video, especially if it's early on, just give it a little bit of time. I'll make sure all the completed files end up on there soon. So yeah, that's how you take a Harbor Freight extension and turn it into a spinner handle with 3D printing. I hope you guys enjoyed the journey I took you on and maybe learned something. I don't know. And I'll catch you guys next time. Later.